We should go there for just a second. Competitive programming is a bit different, I would argue, than normal programming. Or how would you describe what competitive programming is?
It's more about algorithm, how to solve problems, very limited, concrete problems in an efficient way. So normally if I program a robot, I have a purpose. The robot should bring me something, do some task. But in the competitive programming, it's more about a clever data structure or a clever way of...
And what was the criteria to win in competitive programming? It is the most sharp or neat code or the shortest amount of lines?
You can have different rules. So there are programming competitions where you should be fastest, like writing the code fastest or having the shortest code.
Shortest code, solving the problem the fastest.
Yeah, exactly. So there are different competition with different rules, but normally you should clear all the inputs. If you don't succeed in solving all inputs, you get less score. But if two competitors have the same number of inputs that they can solve, then it's the fastest one doing that.
So what's the normal setup for a competition like this? You're given some kind of instruction,
yes,
and you have some time frame. Can you just describe the normal setup?
Today, they are using computer judges. So you get the task formulation on a paper. It can be 7 tasks or 5 tasks. Some of them are short, like 5 sentences, but some of them can be quite comprehensive. So you need to really dig into the problem and try to understand what are they talking about. And it's very clear about how should the input be structured, how should the output be structured, because we have a computer judge. No human will be interfering in the judging process. So you need to really read how many lines should you read from the standard input, how many lines should you print out, and so on. And then you start programming, and you can do it in different languages, Python, C++, Java, or whatever you want. And then you send in your source code to a web interface, and they will compile it and run it, and you will get an answer. For example, you succeeded in 5 out of 10 example inputs, or you succeeded in all of them in this time frame, or you get a compilation error sometimes, or you get memory exceeded. You can get different outputs from the judge. When I was competing in the beginning, you sent in the code to a human, and the human will compile it and try it with different arguments and so on.
Yeah. I mean, cool. And I guess it's rather different then, because you have a time limit as well that you can spend on it.
But normally you have it in a real project as well. From the client, you have a time limit, a deadline.
You do, but it's not that short, right?
No.
Or what's the normal time limit that you have
in a programming competition? It can be 1 hour a problem or something like that, even less sometimes, but 1 or 2 hours a problem. And the problems should be, if you know how to solve it, it should be solvable within maybe half an hour. But you need to know a lot about different data structure, algorithms, and so on. And you can read it online, but it's also, even if you know I should use Dijkstra's algorithm here, or I should use the Simpsons algorithm here, you need to transform the problem and the data to fit the specific algorithm. So it's not only like you have this data, sort it fast as possible. It's a bit more tricky.
So what would be your tips if anyone is interested in getting into competitive programming? What should they do? Should they learn about like basic data structures, basic algorithms?
Yeah, that's maybe the second step. I think you can start working directly, just tinkering around. You don't need to know all our algorithms, or it's hard also to know what kind of algorithms should I know in the beginning. So start to solve the problems. Usually you can solve it in a naive way, and then it will find the answer in maybe 1 hour, 2 hours, 5 hours. But then you can start search on different breadth first search or depth first search, or different sorting algorithms and so on, just to get the grasp of how to think about it.
Yeah, I mean, cool. And there was this new thing from DeepMind. What was the name of it again?
Yeah, they are trying to solve these emo problems, math problems. Is it?
No, it was AlphaCode. It was actually a model similar to these large language models, but in this case, they actually tried to give them just the textual description, if I recall correctly, of the problem in programming competitions, write the program and have it, win this kind of competition. And it's kind of different. You have these kind of codecs and other models that can help you program and write code. But in this case, I think, if I don't remember incorrectly, it was AlphaCode, and they basically trained it specifically for competitive programming tasks. They took historical ones, they gave it the textual description, and they made it train how to do that. And
so they trained an AI to solve typical competitive programming problems.
And I think they didn't beat the expert human, but they came, I think, to the 50%. Or 50 percentile of average human performance, so to speak. But still, it's kind of impressive, right?
Exactly. Yeah, it's really impressive, and it's much more. That is much more impressed than this GPT codex. Right? You write, I want a button on this location. Yeah, it's quite easy to figure out how to have that button in that position, but it's much harder to know what kind of data structure and so on.
Yeah. Do you think, how long would it take until humans are succeeded by AI in competitive programming? Do you think it will?
Yeah, some day, some year it will happen. But I think it will take quite a long time until they are better than all humans, because it's the most challenging problem are really, really hard, even for the most experienced humans, and you then don't have so much data samples on the solutions. So it's hard to tell, but probably before the 30s, so within 8 years.